Hi, everybody. We have a jam-packed session. I will give you a very brief introduction, and then we will get into this. Quick introduction. I'm Lauren Vaccarello. I'm the Chief Marketing Officer at WEKA. If you don't know WEKA, we are the world's only software-defined storage system purpose-built for accelerating AI. If you are building large-scale models, they demand completely new types of infrastructure to help your AI move faster and be more efficient. We'll give you the performance and efficiency and to get more value from AI, but I am the least interesting person on this panel. I want to introduce you to Cécile Robert-Michon. She leads the technical teams at one of the foremost providers of enterprise-grade language AI. Is anyone here familiar with Cohere? They are a phenomenal company. They're just outside. So Cohere builds transformational products with cutting-edge large language models, powering everything from search and chat to summarization and documentation intelligence, all in a secure and scalable way, which is critical for enterprises. Cécile is phenomenal. She brings deep AI infrastructure expertise, and she plays a key role in shaping how Cohere's models evolve to meet the demands of enterprise scales. Exactly what we are looking into today. And then we have Dan Stan, the Chief Technology Officer at Nebius. Does anyone know Nebius? If you do not, absolutely go check them out. They are a next-generation cloud provider, purpose-built for AI. While a lot of the big clouds are built for general computing, Nebius is completely different. They are designed from the ground up to power large-scale AI workloads, and they offer more than just compute power. They have tools, support teams for AI needed to train advanced models. Dan is an incredibly brilliant technologist. He spent his career building complex systems at scale. He's helping organizations move fast without overspending, if you were thinking about that. And Nebius will provide you the infrastructure to get it done. Okay, really interesting topic. I'm going to take off this badge because I'm going to hit it with my hands when I talk. So we're going to talk about a few different things. First, I want to talk about scale. AI needs an incredible amount of scale to get things done. Then I want to dig into this idea of rewriting rules. There's a lot happening in AI right now that the way enterprises had to build before fundamentally breaks and does not work in this AI-first world. And then we'll go into the ROI, the economics of making all of this work, and the commercial viability of AI. Okay, first up. So, Cécile, speed is table stakes for foundation models and agentic AI solutions, as users expect instant responses. We're not willing to sit and wait. But behind the scenes, supporting speed at massive scale creates these very unique challenges. You've seen some of the biggest models in the world. What are some of the key scaling challenges you've faced, and how do you work through this with your team?
So glad to see a lot of people here know Cohere. For those who don't know us, we're a security-first AI company. We work a lot with enterprises to both build foundation models and end-to-end products that are cutting edge. We work a lot with our partners, both as consumers of infrastructure to build those models and products, as well as with our customers as technology partners for them to build custom solutions for the enterprise. Being on the cutting edge means the rules are changing all the time, and you constantly need to rethink what you're doing and try new things. Whether it's rethinking storage completely, or benchmarking and testing new GPU chips before they're even on the market, or, and this is a true story, testing and using a open source release of a project before it's a few hours after it's been released. So I think sometimes when you look at it, it's almost like you're working with a very high-speed train, like the French TGVs, and the train is coming really fast, and you're building the rail tracks just as the train is coming. So you have to be really, fast, but it's very fun.
And it sounds like you to be very agile in those environments. And then, Dan, thinking a little bit about agentic AI. There's longer sessions, there's more complex interactions that are happening, and we're seeing this huge spike in inference and demand and usage. So it's not just about this idea of serving more tokens, it's about how do you make each token smarter. How are you thinking about optimizing both quality and efficiency as you start to build scale?
Well, just pack stuff really tight
Yeah.
and make sure you're consuming only what you're using.
Oh.
So essentially, the only answer there is being as flexible as possible, right? Whether you're talking about hardware infrastructure, or you're talking about the software layer, it's all about being the most efficient, like giving the most efficient solution on the market. And it doesn't matter whether you're talking application level, foundational models level, or hardware infrastructure. So basically, the only thing we see and we believe in is being as flexible as possible. That, for example, is why we're building our product software first, right? Like, we are a relatively small company if you compare us to hyperscalers. But their product and their flexibility is definitely the model for us. That's what we are trying to achieve. So being as flexible, being able to solve the issues and the problems that really small companies or like private individuals are like spawning a virtual machine with one GPU for half an hour to run your small experiment, all the way to thousands and thousands of interconnected GPUs within the cluster, accompanied by a bunch of services, all within the same platform. Because you never know when your next student with a credit card and a half an hour GPU budget will launch a company, become a successful entrepreneur, and come back to you with 1,000 demand.
100%. So you said something really intriguing about this idea of being flexible, and you both touched upon this. And with AI, this idea of being flexible, we don't know what the world is going to look like in 5 years, in a year, probably in 2 weeks. But so Dan, another question for you. There's this notion in infrastructure and technology that if you want flexibility, you have to compromise on performance. You can't have both. Is that true in this more modern world?
The short answer is no. By the way, just to comment on your flexibility, I'm always asked by our customers, for example, like, what's your roadmap for the next year? And I'm always like, well, I have a very particular plan for the next 2 weeks, like as you said, literally. I have a vague understanding of what we're going to do in the nearest quarter, and everything behind there is just a fog, because like you never know. Like we try to be reactive, but we if you try to set the plans in stone, you're going to lose. Coming back to performance, it is a common notion, right? Because if you want to be flexible, you need to virtualize everything. And virtualizing, it's obviously a performance hit. Like, we've known that from the very beginning, so we tried to play around that, essentially. We don't virtualize GPUs. We don't virtualize InfiniBand interconnect because it doesn't make sense. Users want the maximum performance. Users want the whatever they can achieve. Like, we have a lot of work doing on the storage side of things, right? Because like modern systems require microsecond latency, getting over the network to your huge amount of NVMEs. And if you add a ton of virtualization along, you're gonna lose. So if you virtualize and orchestrate the parts that are less relevant to the AI workloads, you can kind of get out of it. So we've recently published like an MLPerf submission, and we've done a lot of benchmarking with NVIDIA according to their own benchmark. And like virtualized platform can achieve like 99.7% of the NVIDIA's benchmark standard. Sometimes 104, but that's another thing.
Yeah. And that gives you this flexibility and still performance, and now you're not locked into something that, to your point, isn't necessarily relevant in 2 weeks.
Exactly. And we're not doing it for us. We're doing it for the AI practitioners. We're the infrastructure company, right?
Yep.
Our goal is to give the tools to Cecile and her colleagues in order to be sure that they can do whatever they need on a budget.
Absolutely. And good infrastructure is what's enabling this innovation and accelerating it. And then Cecile, I would love to talk about the role of infrastructure with you. And it's no longer a technology decision. It can be make or break. It can give you a competitive advantage. So to build infrastructure that can power these large reasoning models and enterprise AI apps, what do you think businesses should prioritize?
Yeah, so for us, we value security and data privacy. We work a lot with regulated industries. Security, data privacy, optionality, customization, they're all at the core of every infrastructure decision that we make. For our models and our end-to-end solution, the latest being North, our platform, what that means is we're available on every major cloud provider, and we're also available for private deployments. In terms of training infrastructure, we take that mentality back to our training stack, and every layer of the stack is designed to be completely cloud agnostic, and we train on a fully cloud native stack. What that allows us to do is to really build a strong relationship with all these cloud providers as well as expertise, so that we can then be really a partner, technology partner to our customers, and meet them where they are, where their sensitive data is, so they can continue to work with their data where it is, and they don't have to move it around.
And then I want to touch on something that you said. You talked about being in highly regulated industries. Having been around the block before with enterprises, they're often more reticent to adapt new technology, especially in highly regulated industries. So there's this common perception that to be on this bleeding edge of AI, you may have to make these trade-offs between innovation, security, privacy. Are you finding the same things?
So I think I would say that's actually what Cohere specializes in. We're really putting security and data privacy first at the core of everything we design. We work especially with regulated industries that have this, more barriers to adoption. Industries like finance, healthcare, manufacturing, public sector, energy, etc. And our platform, North, and our models are all, as I said, designed to be run in private environments. They're optimized for private environments, including air-gapped environments. So that really allows customers to, control where their data lives and make sure that, that they don't have to send their data out anywhere, and they can keep their environment strictly secure, while following the strictest security standards.
Okay, so this is really interesting. So common conceptions are you want performance, you're locked into certain hardware. And Danilo, you're like, no, that's not true. You should not be locked in. You should get this flexibility. And you don't have to compromise security for actual innovation and being on the bleeding edge. So here's another idea that is becoming a more common conception in AI. It's this idea that AI is really expensive. Like, this is incredibly expensive. And getting commercially viable AI, we're a ways away from it. So Danilo, a couple of questions for you. I have this idea that one of the biggest unlocks with commercially viable AI is getting the economics right. How do we actually do this when every decoded token can cost orders of magnitude of what it costs in the past? So for you, what are key decisions you've made, whether it's infrastructure, architecture, product strategy, to make AI not just powerful, but also cost effective?
To be honest with you, we kind of don't. And let me elaborate on that. Cost-effective infrastructure is the thing, right? So because you can compare price, performance, etc., etc., etc. Cost-effective AI is actually in its own league, because ultimately what we see now, like the push for enterprise AI, right, for all the advancement in autonomous software engineering, right? AI starts to kind of fight for the HR budget now, right? Which are tremendous. So to be honest, I think every everyone who is building applied AI solutions right now, they should probably be on the other side of scales. The more capable AI systems you build, the more intellect per token you can provide. It's almost always a better trade-off than to try to balance the costs between the system being actually smart. At least for the first iteration, right? Of course, later in the life cycle, all kinds of optimizations. Let's build a smaller sized model that is still performs exceptionally well in these narrow scenarios, etc., etc., etc. But for the initial push, and that's where we are right now, right? We are in a very early stage of AI adoption, actually, right? The initial push will always be, we don't care about the money, let's just make a thing that works. And we will figure out the optimizations later. Because optimizations usually come with the software, right? Yeah. Software takes a little, it's not the same time as the hardware takes, but it takes time. Yeah. And if you can come up with a solution and reduce your time to market today and have a proper result, go for it. Yeah. You don't need to worry about the cost. That will come later, at a later stage of adoption, at a later stage of maturity of the whole ecosystem.
I know, I think that's great. And then, so thinking about this idea of how do you apply software in terms of efficiency, and how do you think about if we are looking to focus whether on a short or long-term ROI? Because I agree with you, we should not let ROI slow down innovation. We are on day one of the AI renaissance, and we should be leaning into that as much as possible. But are there any lessons, Cecile, that you've learned about how to maximize some efficiency, maximize some scale, where you're not compromising performance, so you start to get some better returns?
Yeah, I think actually I would put it another way. I think you can, by trying to maximize efficiency and by getting really creative with the software, you can sometimes unlock performance gains that you hadn't really been going after otherwise if you were just trying to just throw more compute at the problem. So I do think they go hand in hand together. For us, that applies, on the serving side. Our latest model, Command A, can run on just 2 GPUs, which really helps these enterprises that are trying to adopt it at production scale. And on the training side, we're also, of course, thinking about efficiency at every step of the training and model development and serving. For example, I think we worked together with WEKA recently to rethink completely our storage layer and build a converged storage solution that essentially reuses our GPU servers to run a unified storage and compute layer, such that we can use our NVMe disks, our spare CPU cores, and our existing network infrastructure, so no net new resources. And that gave us up to 20 times checkpoint performance improvements over traditional object storage. So we were going for efficiency, and we found performance.
I think that's great, because we are not going to have an abundance of resources. Unfortunately, there isn't going to be all of the spare compute power. It's utilizing what we have as much as we can, and then if we actually get more, doing something new with it. So we are about at time. So one last question for both of you. What advice would you give the people in this room that are looking at how do you build for scale for the future? It's a good forward-looking question.
You want to go first?
Sure. I think there's some things we definitely need to unlearn in order to learn new things. I think AI is moving much faster than anything we've ever seen before. So, one interesting point we were talking about earlier is how do we think that, these enterprises that have had these legacy software in their stack, how will they deal with legacy AI, right? What will that look like? So I think there are a lot of open questions there with how we evolve the technology. Enterprise adoption is behind consumer adoption, and that's what Cohere is really focused on solving. So yeah, I think just a lot to unlearn.
Yeah, I'd second that actually, right? Because if we've learned anything in the past 2 years, is that a lot of common conceptions, or rather common misconceptions, have questioned very openly now, right? Especially on the performance side. We are now seeing the performance demands from storage, from networking, from GPU itself at a level that was unimaginable a couple of years ago, right? And if someone tells you that they were ready for the scale and did not hastily build everything they could in the past 2 years, not knowing what will be the next, well, what will the next demand be, they are lying to you. So I think it's the only question, like, unlearn everything you knew before, look at it as a clean sheet, and check out what can you do to address the problems of today. Don't address the problems of tomorrow, because those are already solved and probably are not needed anymore.
I think that's excellent advice, and it is ultimate flexibility in what we're doing, because I don't know what next month is going to be, so we might as well be agile. All right, thank you so much for being here. Thank you, everybody.